Do men score higher on average compared to women on their statistic finals? Final exam scores of 10 randomly selected male statistic students and 10 randomly selected female statistic students are shown below. We're going to assume that both populations are normally distributed, and we're going to let the first group or the first average be the average of the men. So we're talking about averages here. So you can see it listed several places through here. When we're talking about averages, we're looking at means. So we are going to use either, in this case, 2-sample z-test or 2-sample t-test, because we've got 2 samples, and with means we use z or t. Now, to narrow it down to whether we use z or t, if you look through here, there is no information given to us about the population standard deviation. And the only information we have are the 2 samples. So when we do our calculations, the standard deviation that the calculator gives us, because this is a sample, is going to have to come from the sample standard deviation. And we're going to be doing this at a 0.01 level of significance. So it says to let the first group be the males. So we're going to let M1 be the mean from the male sample. And we're going to let M2 come from the female sample. And it's asking if men score higher on average. So when we do set up our test, we're going to do a right-tailed test. We're looking to see if the mean for men is greater than the mean for the women. Okay, so for our null hypothesis, I'm going to put M1 is equal to M2. Then for the alternative hypothesis, I'm going to put that we're going to do a right-tailed test. So when we do our right-tailed test, our graph is going to look like this, where we have the right tail area filled in, which means if 0 is the mean in the center, then we're going to be looking at positive numbers. All right, now because we're given the data, I'm just going to go ahead and enter the data. I already preloaded mine, but just to remind you where to do that, you go to Stat and to Edit, and then you put your men averages, your male averages in here, and then the women averages in the second group. So take a minute and load that in, double check to make sure you entered all your numbers correctly. Once you have your numbers entered in, we're going to do a 2-sample t-test. And we're doing a 2-sample t-test because we do not have the standard deviation from the population. We only have it from the samples. So I'm going to go to Stat again and over to Tests. And I'm going to choose 2-sample t-test. Now this time, instead of doing stacks, if we use stacks, we need to know what all the averages and the sample standard deviation is and everything like that. To save us some work, we're going to do it directly from the data and have the calculator find that information for us and do the hypothesis test all in one step. So I'm going to arrow over to data, and I'm going to tell that the first group is from list 1 and my second group is coming from list 2. And then I want to make sure that I choose right-tailed test. So I want to choose the test where it says greater than the second mean. And then I'm going to come down and I'm going to hit the calculate button. And it's going to give me all my information. So it says my test statistic is 1.8981. Let me write this down. So this is going to be t for my variable, for my distribution. And then for my test statistic, rounding it to 4 places, I got 1.89. Whoops. Let me fix this. Okay. So I've got 1.8981. That's my test statistic. And then my p-value, I get 0.037, because that 9 bumps that 6 up to a 7. Now, the next step is we want to find the critical value for the rejection region. Here's our rejection region here. Let me do that in red. I like to do my rejection regions in red. Just habit, I guess. So here's my rejection region. Now, I got to find the cutoff point for that rejection region. Now, for the level of significance, we said that was 0.01. So we want this area here, shaded in red, to be 0.01. And because we're using the t distribution, we want to do inverse t, which means we also need to know our degrees of freedom, which I got right off the calculator here. If I read off here, the degrees of freedom is 17.955516138. For those of you who like using formulas, you can look up that formula online for finding degrees of freedom for 2 sample t-test. The formula is fairly complicated, but if you want, you can look it up online and try it. If not, you can just get it off the calculator. Okay, so now we're going to do inverse t. So I'm going to come down and look at inverse t. And I'm doing an area of 0.01, and my degrees of freedom is 17.9551638. And I'm going to hit paste. Now, I can tell you right away, when I put this in, I'm going to get a negative number because, look, I'm doing the area of 0.01, but remember the calculator does it by default, the area to the left. So it thinks I'm doing this area here to the left. So it's going to give me the negative value, but I know because the t distribution is symmetric, it's going to be the same value over here, but positive because we're looking at the right tail. So for 0.01 for a left tail, that would be over here in this area. That would be negative 2.55 299447, rounded to 4 places. We can do that, but that's going to give me a negative value for it over here. For the right-tailed test, we're going to use a positive number because it's on the right side of the graph and on the right side of 0. So this is going to be 2.553 if we round it to 4 places. Okay, now that's this cutoff point right here. Another food for thought, if that's confusing on keeping track of if it's negative or positive, remember the calculator does the area to the left. So if I want to find this cutoff point using the area to the left, since I know that this area here is 0.01, this area here has to be 0.99. That's the area to the left. So you could also do, if you want to get the correct sign, just keep track of whether you're doing left-tailed or right-tailed. I could redo inverse t, and instead of putting in 0.01, I could put in 0.99, and it will give me the same number, but it will give me the positive value of that, because remember the calculator gives you the area to the left. So that's one way to keep in mind how to figure out whether it's negative or positive if you want to actually put in the area to the left Or you could just always put in the alpha level and just keep track of whether it's a right-tailed or left-tailed. You just have to keep track of that no matter which method you use. Okay, now for the critical value, we got that was 2.553. Now we're going to use the test statistic to see if that falls in the rejection region. The test statistic we got was 1.8981. That 1.8981 falls between 0 and 2.553. There's where it falls. That's my test statistic. That is not in the rejection region, so we're going to fail to reject the null hypothesis. We're not going to reject it. When we're looking at it in terms of the p-value, we got a p-value of 0.037, which is greater than our alpha level. Whoops, that's not very nice. But our p-value is greater than our alpha level, which is 0.01. So again, because the p-value is greater than alpha, we're going to reject. Oh, sorry, not reject. Whoops. And then because we fail to reject, we would say that there is not enough evidence to conclude that the population mean score of men's statistic exams is higher than women's.